Okay, so we're gonna go through those questions and we're gonna go through with you. We says find the fourth degree Taylor polynomial for cosine of x about x equal to 0. Then use the polynomial to approximate the value of 0.8. Now, here's the things that a lot of you guys are confused, including Katie, including Xavier. This part is fourth degree Taylor polynomial. So they say it's not, the other way they're gonna tell you is a non-zero for term. Okay, non-zero for term.
So just the first four terms?
Yeah, but this one is a fourth degree. So if you see fourth degree, automatically think about this as x to the fourth. Yeah, I'll make it bigger, sorry.
Most commonly think it's 4 non-zero, but it's also
Okay, so automatically, if they ever say fourth degrees, then it's x to the fourth. Now, if they told you non-zero, first four non-zero term, then you just list down first four terms. So that will end up to be x to the third degrees, usually. It depends on what happened here. Now, remember we says on AP exam, you had to remember what is the cosine of x. Now, just assume that I don't know. Assume I don't know the cosine of x. Can we use Taylor form?
Yeah. Yeah.
Okay, Taylor form, we can do f prime of f of x is equal to cosine of x. F prime of x equal to negative sine of x. F double prime of x is what? And f triple prime sine of x. And the f fourth prime is cosine of x. And we're gonna say f of 0 is what? 1. F of 1, f prime of 0 is what? 0. F prime double prime of 0 is f third prime of 0 is what? It's 0. F4 is gonna be what? It's 1. So you guys already know this and also know what a cosine of x. A lot of you guys don't remember the power series. The power cosine graphs start on the top and looks like a parabola, remember? So that should be able to tell by first full function. So if I do the Taylor series, I'm gonna do f of 0 plus f prime of 0 over 1 factorial times x to the first plus f double prime of 0 times 2 factorial x to the second plus f triple prime of 0 of 3 factorial over x to the third, and so on and so on. So f of 0 is equal to 1 plus 0 plus x squared over 2. Sorry, is that negative? Is that negative 0? Yeah, that's negative. That's negative. And then plus 0 plus x to the fourth over 4 factorial. So you should stop right here. And some people says, hey, do I stop at n equal to which one? So n is equal to 4 in this case, right? Because n equal to 0, n equal to 1, n equal to 2, and n equal to 3, and n equal to 4. And Darby is confused. So Darby confused. Where's Darby confused? Darby confused because Darby McCoy, the soccer player. Yeah, Darby. So she says, wait, why do we not why do we exist? Why do we use n equal to 4 rather than n equal to 5? And n equal to whatever. So I'm gonna show you here. So remember sine of x, if you did it in term of power series, no, sorry, cosine of x. Cosine of x is equal to negative 1 to the n x to the 2n over 2n factorial. So she said if I plug in n to the 4 here, I'm going to get x to the 8. But remember, this is fourth degree Taylor. So you go into n equal to 4 on the Taylor series. Do you guys understand the difference? One is Taylor series. One is this is a power series.
But we're not including non-zero, right? So like we're trying to.
Taylor series and power series are different.
No, we use in Taylor series to get the power series because once we write out this, right? Once we write out this, we use this to write it in this way. So that way, at all the zero, the n equal to 0, we exclude them. So that we change the power series. Does that make sense?
Yeah.
Because you're skipping every other step on that one.
So when you write down general term from here, it's based on.
Because we don't.
Is that okay?
Mm-hmm.
That's okay, right? Summation
More than
n
okay.
equal to 0 to infinity. So that is why the n is 4 here rather than n equal to 4 here because this is power series. This is Taylor series. So please understand, and I thought that before Darby asked me, so I didn't understand what her question is. So I want to go back to readdress that. And I do apologize. I'm not a good teacher in this particular part. I'm trying my best. So is that okay?
That makes a lot of sense.
Okay. So now let's talk about the Lagrange. We're only gonna do this one, and this is the only one you need to know. And Lagrange remainder is r to the 4, but if r to the 4, you're gonna go to the 5th term. Remember that formula is what? The formula we had write down earlier. Can somebody tell me?
What?
F to the n
Equals
plus
S minus.
1 times, or of z over n plus 1 factorial times x minus c to the n plus 1.
Can you say that again? F to the
This is
n
F to the
of
n plus
z
1. F to the n plus 1.
m plus 1. This is m plus 1, right?
Yeah.
Yeah, but that.
Well,
that-
n is plus 1. Yes.
And equal to x minus c to the n plus 1.
Yeah, times
Is that
x
R and
minus
N
c
on
to
the
the
left?
n factorial on
Okay.
top.
You said
M
it was
factorial.
R, so
Thank you.
something.
So in this case, which is we want to know the error at 4, so it'll be 4 plus 1, so it'll be f to the 5th of z of 4 plus 1, so it's going to be 5 factorial times 0.8, and c is going to be 0, so because we're using center above 0 to the 5th power.
What does Z mean?
So this is the part that I am kind of confused about, and the book didn't really explain it. So I'm gonna say this is what the answer sheet says. They says f of 5 of z has a maximum value at 1.
Where does it say that?
This part has to be at 1, according to my answer sheet. Okay, this part too has to be at 1. Because if you take the derivative, it doesn't matter what value you plug in, your maximum is going to be 1. So we're going to replace that with the 1 over 5th factorial times 0.8 to the 5th. So once you got that, you should get 0.00273066667.
Well, I'm just like a little confused. So like, what is z?
So I hear, I'm saying, I don't know. I'm going to tell you the flat out says, I don't know. But according to answer sheet says, if f fifth of z, the maximum you get to derivative of the cosine of x is going to be 1. So we're going to replace that as 1. So that's going to be 1 over 5 factorial. So this becomes the error. Now, this error is different than Lagrange AST remainder errors. This has that part that is going to be a little bit different. Okay? Usually, AST, you just have to plug in a to the n plus 1. But in this case, you have to do the Taylor form, a Taylor form of the error. So then you're going to have this part, which is, I have no idea. But according to answer sheet here, cosine of x, the maximum of derivative of cosine of x is going to be 1. So that's why you put in 1 here, and you're going to work out like this. Now let's talk about the next question. So
We
cosine,
didn't find the interval yet.
yeah, so we're going to say cosine of 0.8 the interval is going to be between 0.694336 to 0.699797 equal to I.
Where do you get the 6-9 from?
Is from the first part. The first part, good question. So if I want to say cosine of 0.8, that's equal to 1 minus 0.8 to the square over 2 factorial plus 0.8 to the 4 factorial. Is that okay? Is equal to 0.697. That's equal to A. The A is this part.
Yeah, that makes sense.
Okay, so moral of the story is here is, can you figure out a McLean or Taylor series of some type of polynomial? Now, once you can, the second following question will ask you, can you approximate a value? And if you want to approximate a value, you just plug in the value into this series right here. Into this series right here. And you're going to plug in the 0.8. That's going to give you an approximation of 0.697. Now the error I hear, if they say use Lagrange errors, then Lagrange and Taylor, so this is the same. The Taylor's theorem or Lagrange theorem, they are the same. So if you use Taylor's theorem, which is they want you to do this. Now, remember, f5 of z, I don't really care. I know the maximum of cosine is going to be 1, and that's it. I'm going to put down 1 here. Got it? And then once you got this, it's your plus minus. So is this plus minus this? So it's going to be between those two values.
0.697 is our critical value.
Now, if you realize 695 is between here, then you say, could this equal this? Yes.
Sorry, what do you?
Yes, because if it's an
It
interval,
falls in our
It
confidence
falls-
interval.
falls.
This is our confidence
It
interval.
falls-
brother.
Whatever you
have to
say.
write-
This
Because
is basically
it
a
captures
100%.
the
This is
true-
a 100%.
Let's construct a 99.9% confidence interval.
Let's not.
It captures the true something between the interval of whatever.
True
It
meaning of
can't-
Lagrange
it's the
theorem.
true
Okay, so I'm gonna skip this particular questions here because I don't know why the answer sheet says E for the maximum value. So I don't want to take a chance on this question, but we can.
I know
Why?
why. Actually, first, can you scroll up for a second? What did you write to the right of the, to the right of that parentheses for that interval in the bottom right?
Oh yeah, it looks like equal to 1. But
Yeah, did you put equals 1?
No, that's I interval.
Oh, the interval. Okay. Okay. So,
I want to play with the
Okay, so why is the numerator E?
okay,
though?
so f of z. This is like what I got from watching the video.
Mhm.
F of z is basically the maximum value that the equation reaches within the given interval, like within the interval that they give you.
Oh.
And because 1 is the highest number, is that like in this interval?
Thank you, Xavier.
Yeah, and it's constantly increasing. E to the x is a constantly increasing equation, so the maximum that reaches right now is e.
Thank you.
Oh.
Okay, so now we should be able to do this question now. Find the interval. Can you guys do it? No, we should be able to do it with the Xavier's help. Thank you for Xavier for looking up the video. I should have done that, but I didn't have
No
time.
problem.
Oh, you almost put me down.
You told us already. So I don't do it.
So using the remainder theorem, which is we're gonna write it down. No, we have to figure out what is a 4th degree polynomial. Do you guys know 4th degree polynomial?
Yeah. Oh, let me list first.
E to the x, e to the x, e to the x.
No,
e to the
no,
x.
you
No, no,
no
no, it was-
polynomial.
It's
4 back
1 x
1 plus x
plus x squared over 2 plus x squared over 3. Yeah.
It's 3 factorial actually. And then x4 factorial. So just
That's what
So like, we're gonna stop right here, right? So this is gonna stop right here because we're gonna get to here. So what we're gonna do is we're gonna plug in, we're gonna evaluate e to the negative 1. So what do I plug in? 1 plus negative 1 plus negative 1 to the square over 2 plus negative 1 to the third over 3 factorial plus negative 1 to the fourth over 4 factorial. This will be a approximation at the 4th degree theta. Is that okay?
Yes.
Yeah.
That's equal to 0.375. So if I want to find the remainder of this, well, we want to find out what is the error here. It's going to be r to the 4.
What does that mean again? Sorry. Approximation. Sorry.
Yeah, this is the error part. If I want to find out at negative 1, I'm going to use that f of 5th of z, right? Over 5 factorial times 0 minus negative 1 to the 5th. Now, according to Xavier, he says, because I didn't read this part, x is less or equal to 1. The maximum you're going to get is 1. So therefore, this part is going to be e over 5 factorial. And that's going to be 1 to the 5th. And that will give you 0.2265. So then it's going to be 0.375 plus minus 0.2265. So we actually understand Lagrange now.
0 minus 5. Hold on.
David, can you explain like why it's E again? Or like can one of you guys like explain like why it's E?
Yeah. Okay. So you know the intervals from -1 to 1, right?
Yes.
Or absolute value. You know how x is e to the x is constantly increasing.
Yes.
Yes.
So f of z is basically the maximum value that the equation reaches within the interval. And because 1 would be, yeah.
Oh.
Because that's when, so e to x is at its greatest value within the interval at 1. Because 1 is its upper bound.
Bet that up, Zed.
It says error when so if it was something where the maximum value was like not at either one of the ends, would you have to take the derivative and find it?
Probably, yeah.
Well, I hear they will give you a restriction. The reason why they give you a restriction is because otherwise it's diverge.
Yeah.
It could be your infinite value, could be like infinity.
Yeah.
So that's why they have to give you a restriction. Now, if a sine of and cosine of x, it will work between -1 to 1. Now, if I were to approximate 2 sine of x, then your maximum should be 2 rather than 1. So those are the things that you should pay attention to.
For example,
Now, go ahead.
here the maximum value for cosine wasn't at either one of the ends, but we just knew 1 was within the interval.
Yeah.
So normally, I guess you would have to take the derivative.
Okay, how about this? You guys gonna try to do 3 now? And you guys, you can use calculator?
Well, me and you doing it.
Wait, the answer to the last one was 0.375 is plus or minus 0.2265.
Yeah.
Well, then awesome.
Let's do it.
We'll pull up the question.
Dude, stop.
You didn't have words and stuff.
So like I said, it takes 5 years to master teaching the topic, and this is my 2nd year, but we're doing a good job with Xavier's help. I have to give credit to Xavier here.
Stat harder.
You want to do math competition for stats?
It means they could be your stats guys.
Yeah, we could.
And Katie
And Katie.
and Tyson.
We're better.
Yeah. Well, honestly, we are better.
You're better than Katie?
They talk the entire call. They don't pay attention.
Yeah, they don't. They just, it's constant talking.
You know we're live streaming. We're talking crap about them.
It's okay. They can hear it. I'll say it to their face.
Yeah.
I'm not scared.
Seriously.
They're
The thing has to be on them constantly, and they don't change.
Sometimes I just switch games.
No, don't say that. She's nice. She's really nice.
Sorry, Katie, I apologize.
You should be. She's really nice.
X equals or is less than or equal to 75.
Yeah, so that kind of told you what you need to do.
What does it say?
Let f be a function that has derivatives of all orders for all real numbers.
Oh, and that's nice. It already gives you the maximum.
Yeah, they already give you the maximum, which is a nice thing.
Assume that f of 5 equals 6, f prime of 5 equals 8, f double prime of 5 equals 30, f triple prime of 5 equals 48, and f to the fourth of x is less than or equal to 75 for all x in interval 5 to 5.
Are you used to the sheet?
Find the polynomial of x equals 5 for f of x.
Oh, third degree. Oh, that
Third degree. So like we need to find the
third degree.
Yeah.
Burn.
Okay. Let's use our brains, put our brains together. We got this. Remember?
Write down on your paper. It doesn't have
You
to.
don't
This
need
is
to.
they already give you all the information.
Yeah, they gave us each other the value. So we don't need to have. No. Okay, but like no, just Oh right. What do we do? So we need to find function. No, they said we don't need it.
It's these days. So yeah, we don't need to find the function.
Find the third degree Taylor polynomial.
Yeah. So you don't need to find the power series for that.
So it's like 6 plus 8.
Use Taylor. Use Taylor form.
Yeah, just keep listing terms until you get x to the third.
Oh yeah, it is third degree. Oh, yeah.
30 over 2.
Do you?
Sure, it was good.
I didn't wash my shorts. My teal shorts.
Last done it equals 75.
Isn't it the sun?
For the good luck.
I don't know. I just got home. I was writing yesterday, and then we're writing it tomorrow.
All right, come on, get to work.
That's what root beer.
Get a paper and start working. They are at least working on board.
It's not on 48 or like
Oh
Do we count this one as 0? Like, is x gonna be 0 on this one?
usually
E zero.
Yeah.
Well, it's
okay.
Taylor, so wait, no, it's not. Yeah, no, so it could be.
Yeah. Taylor says the center isn't 0.
It has about 5, which is 0.
They say center f5.
So x minus 5
Yeah.
to the end.
Wait, but is.
If you find the polynomial by simplifying the
Yeah.
parts of the Taylor.
So it's funny, is this.
Yeah.
0? Or is it.
You can also just leave that as is. Oh, hold on. You didn't do x minus 5 to the third here.
Yeah.
And it's a whole square.
Most likely.
Yeah, I didn't write the signs in here. But,
Oh, okay.
0.
No, the signs don't matter. They're all positive. I just but the
well, I
power.
I meant the power.
Oh.
Over 1.
I said signs, but I meant power.
1 plus 5.
Power series.
That'll. Rn.
Is that why it's called the power series? Because the power increases each step in the series.
I don't know.
And 30.
Oh, n plus 1 would be 4.
Oh,
What is it times x?
Times x minus 5. Y x plus
5 times 8. You picked the polynomial that,
Yeah.
Thinking we'll
but you didn't simplify it that much though.
What do you mean? I simplified as much as you can. Well, don't distribute the power.
Yeah, I was gonna distribute.
No. Never
Don't
do that.
distribute power, no. You just keep it the way it is. Because when you do an approximation, they're gonna subtract it off,
It's,
and they usually do the power.
it's perfect just the way it is. Okay.
Like that one.
Do you guys finish the first part?
Yeah.
almost.
Like part A, right?
Yeah.
Oh, yeah.
30 over.
So remember, it's Taylor series is f of c plus f prime of c over 1 factorial times x minus c plus f double prime of c over 2 factorial of x minus c to the second plus f triple prime of c over 3 factorial x minus c to the third, blah, blah, blah. And then we're just going to write down this part, f of 5, because we say c is equal to 5. So that's going to be what? 6? Are we doing okay?
Yeah, 6.
Plus 8 over 1 factorial times x minus 5
30.
plus f double prime, which is 30 over 2 factorial. And you don't want to simplify because you don't want to simplify and simplify it wrong. So it'd be x minus 5 to the second plus f triple prime, which is what? 48
Yeah, 48.
over 3 factorial x minus c to the third. Do I stop here? Yes, I stop here because they say third degrees, and I stop here.
Way to go.
And that will earn you 2 points here on AP exam.
Sweet.
Oh, that's 2 points right there, Will.
That's 2 points.
You got 2 points, Will.
Wahoo! Wahoo!
Oh, but wait, I did it wrong.
Oh. Okay, what do you use for the
48 over
radius?
6.
Now, how do I plug in?
Paragon.
How do I do this? It just plug in 5.2. If you don't have a calculator, just write down this. It's going to be 0.2 plus 30 over 2. That's going to give you probably, I can simplify that if I wanted to, but I can simplify this. 15 to the 0.2 to the second plus 48 divided by 6 is what? 48 divided by 6. 8.
6 times 8.
8 times 0.2 to the third. And that should give you some type of value here. I don't know what the value is.
Oh, sorry, let me calculate. 2 to the
8.264.
15 times
I got
0.2.
8.264 for the thing.
Yeah, do you guys understand so far?
Yeah.
Okay, what is the maximum error in this? Right, so we're gonna use Lagrange. Lagrange is gonna be what? Or Lagrange or Taylor form. So it's gonna be for the which term? We stop at third degree. Now what we're gonna do? We're gonna do m plus 1. So it's what? The fourth term. Now the nice thing is at the fourth term they actually told you. So I'm gonna write down fourth of z over 4 factorial times the 5.2 minus 5 to the fourth. Now this part they already told you what's the maximum.
75.
75. Just plug in 75 over 4 factorial of 0.2 to the fourth, and that will give you some type of value here. I think you're gonna get 0.005.
We've always done that.
It's fine.
So be 8.264. The smallest value is gonna be 8.259, I believe, and this is 8.269.
Can you just leave it as plus or minus?
You can, I mean,
I don't think.
I probably will leave it like this, and that will be your interval.
Robert, it's fine. Cool.
And last one is a plus 1 point here.
Yeah, when we get back, we play basketball.
Oh, can we?
Oh, wait.
Mental health,
Wait.
Yeah.
No, Monsieur, part D would be no, right?
but basketball's in my car though.
Okay.
What did you do?
Don't worry about it, Mr. Yeah.